My name is Scott Ward. I'm a solution architect with Amazon Web Services. Specifically, I work on our partner team. So I am focused on technical enablement, both for consulting and technology partners. I'm based out of Seattle. I've been with Amazon or AWS for the past 15 years. I have worked for 13 years on our internal financial systems, focusing on payments and financial integration, an area where the database was actually a very key part to everything that we were executing. And for the past just a little over 2 years, I've been in this role at AWS. So today we're going to go ahead and dive into the relational database service, take a peek under the hoods, talk about how some of the things work, and talk about how features that are available that you can take advantage of to better improve your experience and usage of RDS on AWS. Oops. There we go. Okay, so what to expect from today. We're going to do a quick overview of RDS, really quick on that one. The expectation, this is a deep dive session. The expectation is you've heard the highlights about RDS. We don't need to spend much more time on those. Going to dive into what security is there for you to implement when it comes to RDS. Take a look at what you get from a metrics and monitoring standpoint. Discuss how high availability can be implemented on RDS. Look at scaling on RDS, things that you can do, and maybe some interesting tricks that you can do to maybe automate some of your scaling activities as it relates to RDS. Take a look at backups and snapshots, and then briefly touch on migrating to RDS. So RDS, what is it? Once again, this is a deep dive. We won't spend much time on this. No infrastructure management. AWS takes care of all of that. They take care of the operating system, the database server. They take care of managing all that infrastructure for you. Instant provisioning. When you need a database through a few clicks in the management console or some entries into the APIs, you're able to provision and launch and get a database up and running in a matter of minutes. Application compatibility. There's 6 different database engines that are offered on RDS. There's a good chance that if you're running one of those database engines today that you may be able to use it on RDS as well as many third-party applications play just nicely with the database running on RDS. Cost effective, RDS uses a pay-as-you-go model. So you only pay for the amount of storage you provision. You only pay for the amount of time that your database server was actually running. Scale up and scale down. You can resize your database environment on RDS to meet your current demands, whether they be higher demands or lower demands, and get yourself the most performant database possible as well as the most cost-effective database possible. And when you think about how you would do that in a normal on-premise data center, you'd have to have a lot of extra infrastructure lying around in order for you to be able to do that scale up and scale down activity. So it's a very key benefit of what RDS offers. So the 6 engines I mentioned, divided up here into these 3 columns. We have commercial, so the Oracle database, Microsoft SQL Server. In the open source side, MySQL, Postgres, and our newest entry, MariaDB. And then Amazon Aurora, which is our Amazon-built database engine, leveraging a lot of the properties of the cloud, and it's a MySQL-compatible database engine. So RDS, Relational Database Service, is a managed service. So there's some trade-offs when you're looking at using a managed service. It's fully managed at the host and the operating system level, so you don't get any access to the database operating system when you're using RDS. So that's going to give you some limited visibility into being able, or limited ability to be able to modify any configuration that you might normally be going and modifying at the host level for your database. And it's going to give you limited access to any functions that rely on configuration in the database as well. It's fully managed storage, which is great in some ways. You don't have to worry about monitoring the storage layer anymore. You don't have to worry about are disks failing or do I need to order more disks. That's managed for you, but there's some limits. So from a SQL Server standpoint, you can only go up to 4 terabytes for your database size. For MySQL, MariaDB, Postgres, and Oracle, you can go up to 6 terabytes. And Aurora offers you 64 terabytes. And growing your database is a process on RDS. If you do max out the storage on a database engine, you have to start thinking about strategies about how you're going to be able to continue on, whether it be a sharding strategy or an archive strategy or a delete strategy. These are a few of the customers that are using RDS. There's many more that are not listed here. You've got Airbnb, Code, Kempinski hotels are using these and using RDS to fulfill or to meet the needs of either their external or their internal applications. and Aurora. I'll address questions at the end of the presentation, if that's all right. And from Aurora standpoint, these are some of the customers we have as well. Alfresco, they're using it to support their content software that's available for customers, and they're using it to support up to like 1 billion transactions and up to 3 million transactions an hour. Zumba is using it to support their over 15 million customers that use their class on a daily basis and taking in millions of transactions a day. Okay, let's move into security. So security at AWS is job zero. I can attest to this personally. Over the last 15 years, I've seen we have a consistent focus on security, whether it be internally or externally, to make sure that our customers are operating in a safe and secure environment. So it makes sense that security would also be a top priority for a lot of our customers. So let's go ahead and take a look at what RDS offers from a security standpoint. The first one, the virtual private cloud, or the Amazon VPC. Virtual private cloud is a way for you to define your own private address space inside AWS. You get to control it, you get to define it, you get to control all the access. When you launch an RDS instance, you launch that instance inside of a virtual private cloud. So you have all the ability to protect and control the access to that database at this point. And there's lots of ways that you can manage that connectivity into your database. So you can create a VPN connection between your VPC and your on-premise database, for example, to control user access, to have an encrypted point of entry into your database. You can use VPC peering. You can actually connect multiple VPCs in the same AWS region, whether it be in your account or another account, so they can communicate with each other. You can use routing tables to control how traffic moves around in your subnets. And you can attach an internet gateway to your VPC to actually allow public internet access if you want to. So lots of different ways to manage how your database is actually accessed and protect it at the level you want to. On top of that, you have security groups. So if you're familiar with EC2 security groups, it's the same thing. Security groups are basically a firewall, a virtual firewall around your database instance. So you get to control the protocol of traffic, the range of ports, and the type of traffic and the source IP address of the traffic that's coming into your database. You can define a very fine-grained IP address, one single IP address, a range of IP addresses, or you can actually define another security group as a point of access. In the bottom example, we actually have said that anything coming from the application tier security group is okay to enter the database. So if you have a multi-tiered application, maybe there's a web tier in front of that application tier, by implementing this type of configuration, you're basically saying the web tier is not allowed to bypass the application tier and get to the database tier. So you'll be able to establish a policy of trust of where the information is coming into your database. So one of the reasons that security is so important for a lot of our customers is that they have compliance that they need to meet and fulfill, whether they be external compliance, such as these bodies up here, or internal compliance that they just know that they need to fulfill. AWS has lots of different customers across the enterprise, the public sector, and the startup space, operating a lot of different applications and a lot of different workloads. And some of those require that they meet the compliance requirements for certain regulatory bodies. So on the AWS side, what we've done is we've worked with the compliance bodies that you see listed up here to actually certify the RDS platform so that you can run compliant workloads on top of RDS. Now, what that doesn't do is it doesn't just mean that once you plug your application in and run on AWS that you're automatically HIPAA certified or PCI DSS certified. It means that you don't have to worry about the infrastructure portion of that anymore. It's part of the AWS shared responsibility model. AWS takes care of securing that RDS infrastructure and the service itself. You as a customer are still responsible for your security on top of that. So you and your security experts still need to make sure that your application is following all the right requirements that need to be met from a compliance standpoint. You're then able to take the attestations that our third-party auditors provide around the RDS certification, marry that up with your certification findings from your application, and end up with a complete audit finding or compliance certification that your whole application is running at the level that it needs to be. Here is a listing currently of the engines on RDS that have these various compliance certifications, so pretty broad coverage between MySQL, Oracle, SQL Server, and Postgres. Okay, SSL. database encryption. So encryption of in-transit traffic is a key requirement for some of the compliance bodies that we just showed here, as well as just in general, internal companies' requirements. So all 6 of our database engines offer support for SSL encryption. Each one of the engines implements it a little bit differently, but you can implement that encryption for all 6 engines to ensure that you have a fully encrypted pipe between 2 endpoints that are communicating with your database. And then staying on the encryption front, at-rest encryption. At-rest encryption is a very important requirement for a lot of our customers. Once again, often to fulfill compliance needs that they have. We offer the ability to do at-rest encryption for all 6 of the database engines. There's no additional cost for our encryption service. And once again, it's there to support a lot of the compliance requirements that you may have. And when we talk at-rest encryption, it's not just for the actual database instance storage. It's also for all the automated backups that you get with RDS, all the read replicas that you're able to implement, and with all the snapshots that you're able to implement with RDS as well. So the way we offer this up is through the AWS Key Management System, or KMS. KMS is a AWS service that allows you to create and manage encryption keys that are tied to your AWS account and that you own. So even though it's a managed service, you still have full ownership of the keys that are generated by the KMS service in your account. So KMS, being a managed service, takes care of a lot of the heavy lifting around the durability, the availability, the scalability, and the security related to managing keys that you would be using for encryption and decryption. And with that, you're able to focus more on your application, building your application, using your application, and just putting the encryption in there, not having to worry about all the other kind of around the edges things that go with managing encryption keys. The way that KMS works from an RDS perspective is that when you're launching an RDS database, you choose one button. Do you want to encrypt or not? When you choose encryption, you can either leave it right at that, and at that point you will get the RDS service master key created in your KMS account. If you want to have a little bit more control or you want to be able to do something different, you can create your own key in KMS, and then you can actually choose that key when you launch your RDS instance. Once that instance is launched, it will reach out to the KMS service saying, I'd like a data key. Once KMS is confirmed it has access to that master key that you just defined when you launch the instance, it'll hand it a data key. That data key will be loaded into memory, and it will be used to encrypt and decrypt the data that is on your RDS instance. Each RDS instance will get its own data key, and they don't share data keys. Here's another quick flow of how keys are used to protect your data. So we have our application or AWS service, which in this case would be RDS, which is going to be reaching out to the KMS service, saying I'd like to encrypt some data, handing it back a data key, and then using that data key to actually encrypt your data while it's on the RDS instance. So I talked about enabling encryption from the command line, but I also wanted to kind of show you guys some other ways. So just like with all our other APIs, you can do pretty much anything you can do in the console through the APIs. So with RDS, you can create a database instance through the APIs. These are examples with the CLI. One extra parameter, and I'm able to enable encryption on my RDS instance. So that's the top example where I'm saying storage encrypted. If I want to go a little bit further and I actually want to define my own key as opposed to using the RDS service key, it's one extra parameter where I give it the ID of the key that's in the AWS region that I want to encrypt this data with. Some useful hints. If you decide to go forward with using RDS and KMS, you can only encrypt on new database creation. So only when you're creating a new database. If you've got an existing database running on RDS and it's not encrypted already, you can't just flip it to be encrypted. You would actually have to copy the data from that database over to a new database that has encryption turned on. Once you have encryption turned on, you can't remove it. Anytime you implement a read replica and your master is already encrypted, that read replica must also be encrypted. It actually is just done automatically when you create a read replica. There's not an option to turn it off. Any snapshots that you have of your database that are unencrypted can't be restored as an encrypted database. You can't restore a MySQL encrypted snapshot to an Aurora database, and vice versa. You can't restore an encrypted Aurora snapshot to a MySQL database. Any snapshots that you have that are encrypted can't be copied across to another AWS region because those, right now, KMS keys are tied to an AWS region. They can't be used outside of that region. Okay, another way that you can securely control your operating environment on RDS is using IAM, Identity and Access Management. Identity and Access Management controls who can perform actions against RDS. Now, it's a common confusion about what IAM and RDS actually means. IAM is not controlling who can log into your database. You are still responsible for using the normal grant functions that exist in your database to actually grant access to applications or end users to be able to log into your database. Identity and Access Management controls access to the actual RDS service. So who can launch an RDS database? Who can modify an RDS database? Who can delete an RDS database? It's controlling access to the AWS APIs. So it's very important that you have that clear distinction in your head as far as what IAM can do for you and how you would use it. When we talk about IAM access, I've got a couple examples of the policies that would be implemented from an IAM perspective. These are two examples of our managed policies. The one on the left is a read-only policy. You can see where it's giving just access to the describe APIs for RDS. So, allowing you to read all the information about how an RDS environment is configured, as well as read-only access to some of the other around-the-edge services that also support the RDS service, things like some EC2 stuff and CloudWatch. And then full access gives full access to the RDS APIs, as well as some full access to a few other key services that interact with RDS. When it comes to these policies, these are examples of managed policies, but you have the ability to implement any policy that you see fit as far as how you want to be able to control access and who can do what on your RDS environment. Okay, so one of the really important things of being able to operate any database is being able to actually get visibility into what is going on in the database, understanding what its performance looks like, trying to understand where you might have an event coming up, or even being notified of when an event has actually happened on your database. So when you launch an RDS instance, by default, everybody will get access to standard monitoring. This is 15 to 18 metrics that you get access to. The number depends on the instance size that you're using. These metrics are all delivered to AWS Amazon CloudWatch, which is our monitoring service. And you then have access to view these in a graph form, either through the monitoring tab in the RDS management console. You can go directly into CloudWatch and view these metrics, or you can actually call the CloudWatch APIs to get these metrics out, and you can actually dump them into your own monitoring platform or AWS Partners product if you'd prefer to look at the metrics that way. Some of the key metrics you get out of here are things around CPU utilization, storage, the number of database connections that are happening, some basic information. Now, but running a database a lot of times requires you to go even deeper and be able to get more information off of the operating system. And as we talked about before, you don't get access to the host operating system when you're running RDS. So getting access to some of those key metrics can be a little bit challenging. So based on customer feedback, we've actually added enhanced monitoring on the RDS platform. And with enhanced monitoring, you actually can define granularity between 60 seconds and 1 second as far as how much information you'd like. With enhanced monitoring, you get 50 new metrics that are not available in the standard monitoring offering. Things around some deeper level CPU usage, some things around load average, some things around how much of the database file system you've actually used. Lots of additional metrics that people might traditionally be using when they're monitoring and carrying and feeding for their database. You might be asking, like, what's the difference between these? Why are they offered separately? Well, standard monitoring is based on what the hypervisor that actually runs your RDS instance can see. The hypervisor isn't allowed to see everything. It's just merely kind of meant to get that initial instance launched so that you can get it up and running. The enhanced monitoring is based on an agent that actually runs on the operating system and is collecting all these metrics and sending them into CloudWatch for you to be able to view. With all these metrics, once they're in CloudWatch, you have the ability to actually define thresholds. you can say what your threshold is for a particular metric and define an alarm. And then once that alarm is, once that threshold is breached, you can have that alarm notify you in various ways that you either get an email or you can actually take action on them through the Simple Notification Service. And I've got a couple of examples that we'll go into a little bit later on what you might do with that. Another cool thing that exists on the RDS platform is actually event notifications. So there are 17 different categories of events that you can actually get notified on when this particular event happens for your RDS environment. All this information is delivered to you through the Simple Notification Service. So you can once again get it via an email or an SMS. And these event categories cover a pretty broad range of things. Things around like when a backup has failed, or when there's been a failover for your database, or even when somebody's made a configuration change on your database. You can actually get notified when somebody's changed the security group, when somebody's created a new database, or when somebody's modified or deleted a database. So an extra level of visibility for you to have complete control over what's going on in your database environment on AWS. So the next thing that's really key here is high availability. So at the application level, it's pretty well understood some of the things you can do on EC2 and using the load balancer and the auto scaling to achieve high availability of your application. But if the underlying database isn't also architected in a way that's highly available, it's really not very valuable to have your applications architected to be highly available. So on the RDS side, to start off with, this is your bare bones minimal deployment that you can do in RDS. So once again, launching inside the virtual private cloud. You've got a database instance with the attached block storage running inside a VPC, running inside on a particular availability zone. This is good for maybe doing a kind of kick in the tires or doing an initial proof of concept of RDS in general, or for testing something out for a new application that you're building. But when you start getting to the level where you're having production workloads, and it's really important that the database be up and available, running a single availability zone deployment may not be the best approach. With RDS, you have the ability for another option called the multi-availability zone deployment. And it's simply a drop-down box or a configuration parameter when you are launching a database via the CLI to choose that I want a multi-availability zone deployment. And what will happen is that your primary database and storage will be launched in one availability zone of the AWS region that you're running in, inside your virtual private cloud. And then the RDS service will launch another instance that is called the standby instance, and it will have the same storage configuration attached to it, and it will be located in another availability zone in the region that you're working on. And this gives you coverage for a couple different things. It might be if there is a network communication issue or an actual failure with the primary availability zone. It might be also that there might be some issues with the actual database instance itself. There might be some network issues, or it may just become unhealthy. It gives you an option to have something else to fail over to minimize the amount of downtime that you might have for your applications that are using this database. So here's how things might work from or will work from a multi-availability zone perspective when you have a failure. So you've got your users or your applications connecting to a DNS endpoint that the RDS service has provided you, going into the master database. When there's a failure with that master database or the availability zone that it's in, the RDS service will take over because it's a managed service and will repoint that DNS entry to your standby database and make that standby database your primary master database now. So what you have at the most is about a 30 to 60 second failover with that DNS. Your applications need to be a little bit aware of either being able to retry or fail gracefully for that, but the managed service is taking care of all of that failover for you under the hood. From an Aurora perspective, there's a little bit of a difference on how they implement high availability, so I want to make sure I cover that. On the Aurora side, there is an underlying storage layer that covers 3 availability zones in an AWS region, and it's made up of 6 storage nodes. Every one of these storage nodes has the same data on it, so you can have a failure in one availability zone and still be able to run. You can have a failure of a storage node and still be able to run because there are plenty more that have all the data and can continue to run. Then for the database nodes that sit on top of this storage layer, you have your primary node running in AZ1 that is accessing the storage layer, and then we have two secondary nodes, which are actually read replicas. In Aurora, your read replicas are actually your failover targets for any problems with the primary database. So these secondary nodes are plugged into the same storage layer that exists that the primary is using. And the primary is also actually sending all its redo logs to all these read replicas so that they have all the current data that the master has. So when there is a failover from the master node to the secondary or to the read replica node, it is a very quick failover, and there's really no need to replay any data because they have access to all the data already. A little bit more on timelines when we talk about failovers. So on the top is MySQL. So you're going to have your failure detection. That's going to happen on the RDS service once RDS determines that there's been a failure either in the availability zone or with the instance. It will begin the failover process. There's a period of time for recovery to get that standby database caught up and to the level where the master database was. There's also the DNS propagation that we talked about, and then finally your application is up and running. So the recovery time really kind of depends on what's been going on in your database up to that point in time. That can be a little bit variable. On the Aurora side, there's some interesting things that are a little bit different here. So you still have your failure detection that's going to happen and to determine that the master node is no longer healthy and needs, a failover needs to happen. The recovery part is very quick and actually fairly predictable because the storage instances already have, those read replicas already have access to all that data that they've had. So the ability they don't need to be caught up or anything like that. They need to really just be brought online and start working as a master node. And then the application is up and running. And we actually are able to bypass the DNS propagation entirely through the use of the MariaDB driver. So we've been working with the team at MariaDB. They've actually created ODBC and JDBC drivers that work for Aurora. And those drivers actually communicate with all the read replicas for an Aurora cluster. And all the read replicas in an Aurora cluster actually have an entry that says what's the IP address of the current master database. So when Aurora implements a failover from a master to a standby, it actually updates all the read replicas with what the IP address is of the new master database. And the MariaDB driver takes advantage of that, and will use that for your application connectivity. So you have the ability to actually get you back and running up in your application faster because you don't have to worry and wait for that DNS propagation to happen. Okay, so building on top of high availability, being able to scale your database is very important as well. So as your database becomes more popular or more widely used, there may be needs to scale your database in different ways, whether it be to add more horsepower to the existing one or add some additional databases to help take some of the load off of that. So there's several different things you can do on RDS from a scaling perspective. First one is read replicas. So if you have a master database that is getting a lot of pressure, not only supporting write operations, but also supporting a lot of read operations, with RDS, you can implement read replicas. And these are read-only copies of your database that you place in either the same region or another region, and we'll talk about those in a minute, to relieve that pressure from your database master. These read replicas are not only there to support read operations, they can actually also be promoted to be the new master database if you notice a problem with your current master database. There's a couple different ways you can implement read replicas. The first one is just intra-region or within a region. So that means you basically are able to place multiple read replicas in different availability zones of the AWS region that your master database is located in. And you can do that with MariaDB, MySQL, Postgres, and Aurora. And then there's also cross-region read replicas where you can actually take and place a read replica in a different AWS region, a different part of the globe than your primary database is located in. And you can do this for a couple different reasons. You could do it to put a read replica closer to business or end users who might benefit from having that database closer to them from a latency perspective. Or you might do it from a disaster recovery perspective. You might say, I'm gonna put my read replica in another AWS region, and that's what we're gonna fail over to for our disaster recovery process. So there's a couple different ways you could use those read replicas. On Aurora, we've already hit on most of this, but I just want to kind of call out, read replicas are implemented a little bit differently once again. They have a common access to the storage layer, and the read replicas are used as a failover for the primary database. There's no separate standby database that's in place for Aurora when it comes to being able to fail over and use read replicas. I haven't touched on Oracle or SQL Server at this point from read replicas. The reason being is that the RDS product doesn't currently support read replicas for these two engines. But there are ways that you can still implement read replicas with these if you choose to use them. One way is there's several third-party AWS partner products out there that will handle replicating data between a target and a source database on these database engines. The Oracle Golden Gate product can actually be used to replicate data from a target to a source database. Or you can use snapshots, which is a functionality we'll talk about in a little bit, to at least be able to take a copy of a database and move it somewhere else and create another database from it. So there's a couple different reasons why you might want to scale your database up or down. Obviously, the first one is handling a higher load. Your database becomes more popular, your application becomes more popular, you get more users. You have a higher load, you need to be able to scale your database. You need to add more CPU, you need to add more memory for your database to be able to handle the load that's being asked of it. But the other option is actually lower usage. You may size your initial database to handle what you expect to be a certain number of transactions, a certain number of users. And you might find later that you aren't hitting those numbers, and the database is actually quite underutilized, but you're paying for the configuration that you initially implemented. You might want to scale your database down so that it's not as, it still can do what it needs to do, but you're not paying for a configuration that you aren't actually using. And kind of on that note as well is controlling costs. So a scenario I always like to reference is, let's say you have an application and a database that are very heavily used Monday through Friday. But on the weekend, it's barely used at all. Nobody touches it. It just kind of sits there idle. Well, wouldn't it be great if you could actually resize that database down to a smaller size, still have it up and running to support the occasional transaction or somebody who might be working over the weekend, but not have to pay for the larger size database that you use over the weekend, actually be able to shrink your costs to a minimal level when you don't actually need that much on a weekend. That's another reason that you might want to think about scaling up or down on RDS, and there's ways that you can do that. So when we talk about scaling on RDS, as it relates to changing the size of your master database, this is an example of what you do in the management console. You choose your database instance, you go to instance actions, you choose the modify menu option, and then you go and you choose what you want your database instance class to be, choosing it based on the mix of CPU and memory that it offers. And then at the very bottom of that configuration page is the apply immediately option. If you don't check apply immediately, RDS will still make the change. It'll resize your database, but it'll do it during your defined maintenance window. So when you create an RDS instance, you define what your maintenance window is. And RDS uses that not only for this type of activity, but for applying minor patches and things like that. So if you want this activity to happen right away, you need to make sure you're checking that apply immediately option and telling the service, go ahead and do this now and not in my maintenance window. So when we're looking at scaling out, so let's say we're running in a single availability zone model, we want to resize our database. So when we go through the actions in the previous page, we choose to apply now, the RDS service is going to take that initial database instance offline. And it's going to resize it and bring it back online and change the DNS entry and point you at the new database. And here's the events that RDS reports. So when that happens, there's a period of time that your database would be unavailable if you were running in that configuration mode. As you can see from the events here, it's about an 8-minute window for the test that I ran where the database wasn't available because I was using a single availability zone configuration. If we look at the multi-availability zone approach, it actually becomes a lot cleaner. So when I choose to resize my database, the RDS service actually is going to go resize that standby database first. Leave the master database up and running, let it continue to do its work. And then bring that larger database instance in and change the DNS entry to point to that new resized database instance. And then it will resize what was the master, which is now your standby database. Here is, well, first of all, you can see what I do at 6:20 in the morning on a Saturday. But second, the events that RDS reports when this activity actually happens. So you can see that it doesn't actually start the failover for the multi-AZ database until it's actually applied the modifications to the first database instance. So we still see that 8-minute window where it takes to flip over the databases. But the difference here is that it's actually doing a failover so that you're minimizing the amount of time that your database is offline during this scaling activity. So I showed you guys through the management console how you can do that, but you can actually even do this directly through the AWS APIs or through the command line interface. The top one is an example of where I'm calling the modify DB instance API. I'm telling it what the database class it should be, and I'm giving it the apply immediately option. If I leave apply immediately off, it'll use the maintenance window. So if we take that a step further, remember the scenario I talked about where you might want to scale your database up and down over the weekend? The bottom is just a simple cron script entry that fires at 8 o'clock on Friday, and it calls a script called scale down RDS, which could be the CLI command I have above with a particular database instance class that I've deemed appropriate to support my weekend work. And then I've got another cron script that runs at 4 a.m. on Monday, calls the very similar command, but gives it a database instance class to resize my database up to the level that I'm going to need on Monday morning to support my activities throughout the week. And during that time, I've been able to resize to a database instance class that's still sufficient for the weekend, but from a cost perspective is a lot cheaper for me to be able to run. So I've been able to create some variable costs out of the database solution that I'm running. Now the cron job requires some sort of infrastructure to be able to run whether you're running some cheap sort of infrastructure on AWS or you're partnering with another compute node that you've got running. But there's another way to actually do this without even having to have a server in place at all from a scheduling perspective. You can actually look at using a scheduled Lambda function. So Lambda is an AWS service that allows you to create functions that respond either to AWS events or to events that you define and take action. So in this example, I've got a piece of Python code that I wrote that I turned into a Lambda function that actually is calling the same modify DB instance API to modify my database instance. I went to the Lambda console in the AWS console, imported the code, and then I went and scheduled it. And it's nearly the same entry you would do as if you were doing a cron job. And I now have a scheduled Lambda function that will run and execute when I want it to, but I don't have to have any infrastructure around to actually support the scheduling part of that. So in the example of the Friday, Monday scale up, I would have 2 Lambda functions that are scheduled to run at the appropriate time that I want them to scale up and down my database. Now building on the Lambda piece, remember we went and talked about the monitoring a little bit a while ago where you could actually create alerts and have those go to simple notification service and actually take action on it. So what if we could actually maybe, based on a particular event, scale our database based on an alarm that tells us that we need to go to a larger database or do something different? Well, we actually have the ability to do metrics-based scaling within RDS. There's not a service like auto-scaling that exists with EC2 where you can kind of define, I want you to add this many more instances based on an alarm. But what you can do is you can take the metrics that RDS is feeding into CloudWatch, define your alarms, and then once those thresholds are crossed, an alarm is created and it sends a notification in simple notification service, and then you can actually subscribe a Lambda function to that notification that can actually take action on your database if you feel like you need to scale up based on the threshold that you've defined. This is an example of some Python code, once again, that I turned into a Lambda function. It is receiving an SNS notification, and it's actually just pulling out the name of the database instance from that notification, and it's calling the modify command API to actually change the size of the instance. So This is a pretty simple one. There might need to be some logic in here that actually figures out what the current database instance is and steps up one based on the available database instances. It really depends on if you're expecting to scale multiple times or just to scale up once. And additionally, you want to think about your applications here. Do you need to, we talked about them being able to fail gracefully. Do you maybe need to pause your application while that database scale up happens? There may be some few things you need to understand around your application, but the point is here is that there are some options for you to be able to actually take action and be able to have some scaling activities hands-off based on parameters you've defined. You could also even think about doing this for read replicas. You could automate adding another read replica if you felt that the pressure on your existing read replicas was getting too large. Okay, so backups and snapshots. So another key part of operating a database is being able to back it up so that you can recover in the event of a failure, in the event of data corruption, or even to create a brand new database. So on RDS, backups are available for all 6 of the engines. MySQL, Postgres, Mariah, Oracle, and SQL Server offer you the ability to have a daily scheduled backup of your database. We also archive automatically the database change logs. You can retain your database backups for up to 35 days. You get to define how many days up to 35 that should be. And if you're running in a multi-availability zone configuration, we will maintain multiple copies of each backup in each availability zone that you're running in. On the Aurora side, backups are actually automatic, continuous, and incremental. We use S3 as that backbone for backups on Aurora. So the storage layer is actually regularly pushing backups of the logs and the data blocks that it's made into S3. There's really no impact on the database performance from Aurora when it comes to the backups because it's from the decoupled storage layer, and it also offers you the 35-day retention for backups. Both of the database engines offer the ability to restore to a point in time. And when you do this, you go in, this is an example of the management console, you define the point in time you want to restore to down to the second. And when you restore it, actually, it doesn't restore on your existing database instance. It actually creates a brand new instance in RDS. And at that point, once you've done this initial define of when you want to restore to, you are presented with the same parameters you would be doing as if you were creating a brand new database from scratch. So if you're restoring, you might have the ability to restore on a smaller database instance because maybe you're just going to investigate something and you don't need a mega powerful database instance up and running. You have some options around there as far as how you configure that, or if you're restoring to replace production, you could restore to the exact same configuration that you had for your production database. When it comes to snapshots, snapshots are a way for you to implement full copies of your RDS database. And these are different from scheduled backups because you control them. You can run and create as many snapshots as you want of your database. All your snapshots are backed by Amazon S3, so you get the durability and the availability that comes along with S3. And these are used to first of all, keep a copy of a database from that particular point in time, but often used to actually create a brand new RDS instance. And we'll talk about some use cases of what people might do here on the next slide. And if you have snapshots that are already encrypted through the encryption options we talked about, they will remain encrypted. So some use cases on why people do snapshots or might do snapshots. One is to resolve a production issue. If you're the DBA and you start to notice a problem with the database, you could take a snapshot at that point in time. And now you've got a copy of what the database looked like when you were first seeing the problem. You have the ability to, maybe when you get through the issue, to fire up a new database based on that snapshot and spend some time actually trying to figure out what was wrong and what was going on with that database. No need to go running around trying to find more infrastructure to actually bring that database up on. It's just launching a new database and requesting the infrastructure you need at the time that you need it. Non-production environments. So there's often cases where you have test, QA, dev teams who want a database that resembles production so that they know that what they're building and testing actually is going to work when it hits production, and that they have a rough idea of the number of transactions and the schemas that they're currently dealing with. With RDS, you could create snapshots and then relaunch a new database with that snapshot, put it into a different VPC, maybe the VPC that's used by your test team, Copy it to a different AWS account if you use the approach where you have different accounts for different stages of your development lifecycle, and launch the database in that account for that team. Now, word of caution on that, if you're taking a production snapshot and you're creating it and handing it to a non-production team, think about if you need to do any data scrubbing, if there's key pieces of data that maybe you should be scrubbing out of that database before you hand it over to them. Taking a final copy before terminating a database. Maybe you bring a database up to test something out, or just for a short period of time, and you need the data around, but the database doesn't need it anymore. You can take a snapshot and then terminate the database. The snapshot will still sit there. And if you ever need to get back at the data, you can just simply take the snapshot and relaunch a new database and actually go look at the data. Or when you determine you don't need the data anymore, you just delete the snapshot. And then a couple of bullets there around related to disaster recovery. One approach for companies might be to take a snapshot at a regular basis that's different from their backup schedule, that gives them a point-in-time copy of their database, to have that around to relaunch the database. And at times, they will even take and copy that snapshot to another AWS region or to another AWS account as part of their overall disaster recovery, saying, our recovery point in time is this, our snapshots are this, and we will use the snapshots to relaunch our database if we ever have to do a disaster recovery. Cool. All right, just a few things left here. So who is using RDS today? Okay. Who's using a database but on EC2? Okay. And then who, I'm assuming the hands will go up for the rest, but who's looking at going to RDS? Okay, cool. So whether you're on RDS today, whether you're on EC2 or whether you're in an on-premise data center, there's options for migrating to RDS. You can do the do-it-yourself approach where you're just kind of standing up a new database and replicating the data across, or there's some third-party tools out there that'll do it for you. And one of the other options that's out there that's been made generally available recently is the database migration service. This is a way for you to migrate data into RDS or even EC2 running a database. And one of the cool things is it can go across different database engines. You could go MySQL to MySQL or Oracle to Oracle, but you could also go Oracle to Aurora if you wanted to. It will link up the different database engines. It will replicate the data, and it will keep replicating the data until you decide to turn it off. So the way that this works is that you've got your on-premise database. You start a replication instance. You connect it to your source and your target database together. You select the tables and the schemas of the databases you actually want migrated. And the migration service will actually migrate all the data from the source database to the target database. And at that point, it will then continue to sync all the changes that happen on the source database. So you could have this up and running for a month and maybe doing some tests against that target database to make sure that it actually works and that it meets your needs. And then when you're finally ready to cut over, you simply repoint your applications and your end users at the other database. I talked about moving between different database engines, and one of the challenges of that is that the schemas aren't the same. Each engine defines how it defines objects, data types, the way you can use functions are different. So another component of that is the schema migration tool. The schema migration tool is actually something that you can download and run against your database, and it will tell you which of the objects it can actually convert successfully from the source database to the target database. And any of the objects it can't, it will tell you, these are the ones that I could not change by default. These are the ones you need to spend your time on actually analyzing and fixing, as opposed to going through every object in your database schema and figuring out which one you need to convert or don't convert. Okay, so that is the end of the first part. I'd like to first of all thank everybody for sitting through. This is a very hot room in here. Sitting through and listening. I really enjoyed putting this together, and I hope you guys got something out of it. Please remember to fill out your surveys. Always anxious to try and improve and hear what people are saying from a feedback perspective. And so I thank you for your time, and I'll stick around for a little Q&A now. Thank you. Question?
Is the failover from one instance to the secondary instance automatic, and do you have a rough estimate of DNS switchover time?
Yeah, so the question was, is the failover from the master to the standby automatic? And then the second question was DNS failover time. So yes, the failover from the master to the standby is automatic. The RDS service is doing that for you. It has another watcher that's out there constantly keeping track of the master database. And when it's determined to be unhealthy, it will initiate the failover process. From a DNS standpoint, it's roughly like a 30 to 60 second time frame before failover happens for those.
Set up your own DNS to refresh.
You potentially could, yes. If you don't want to wait on the TTL, you could try and refresh faster. Yes, cool. Other questions? Yes?
So let's say you're using KMS or
Okay,
encryption, you have all the accounts set up.
okay.
It helps you in account one. Now you actually want to get your snapshot from east to west. Change your regions. We know that doesn't work, right? Are there any tools short of doing a dump load that can do that?
Right. So the question was, is if you wanted to copy an encrypted snapshot from one AWS region to another with KMS keys, which isn't supported today, are there any tools to do that? Right now, there are not any tools that are out there to do that. But I will tell you, what you're asking for is a very common customer ask. It's the next level of like, hey, I want to be able to use my keys anywhere. I don't have any timelines on it, but I know the service teams are hearing that customer feedback, and I would not be surprised if they're working on that and have a plan to implement it in the future. Yes?
In terms of the monitoring besides CloudWatch, do you allow for like native monitoring, like OEM for Oracle?
Yeah, so the question was, is other types of monitoring, specifically like OEM for Oracle? Yeah, actually, you can implement OEM right on top of RDS, and we actually have public documents that talk about how to link up OEM on top of RDS. Get over here. Yeah. Yes. Sure. Sure. So the question was about Postgres and HIPAA compliance. What I can tell you is that in most cases, compliance and getting an engine certified for compliance is more of a timing thing. It takes a while to work with these auditors and the compliance boards to actually get them comfortable and go through all the tests that are required to get it compliant. I can tell you that our teams, that is another piece of feedback we get, is to get all the engines compliant. I know that they're working on it. I don't have any timelines that I can share on it, or my understanding is in the works, but I don't have any timelines to share, and I don't know if it's a technology or a timing thing with the certification. Okay, there was a question here?
Do you know if there are plans to make Postgres have rerouting across region as MySQL?
So the question was, are there any plans for Postgres cross-region replication? I'm not aware of any plans. Once again, it's all dependent on customer feedback. The product teams may have gotten that feedback. It may be something coming. I just don't know. Yeah, sorry.
So if there's no read replicas for Oracle, is failover a role?
Well, so failover, if you're using this question was about failover on Oracle. So you can still use the high availability, the high availability configuration on RDS to have that failover for Oracle. That's totally possible. That works for all 6 engines to have that. But if you want to have an additional read replica, because that standby is actually not, you can't access that standby in an HA configuration. So if you do want something in addition to that, then you need to start looking at the tools for like a Golden Gate or something like that to get another Oracle read replica. Okay? Yes?
What's the format of the snapshots? Can you pull those into like a local instance or that?
No, this question is if in the formats the snapshots be exported. The snapshots are only work on RDS. You can't pull them, import them into like another database that's not on RDS. They will only work with RDS. They can't actually be exported at all.
Get a full database backup out of Amazon.
Depends on the engine. There are some public docs, I know around like SQL Server and Oracle about how to do that. I don't know if you can ever get a full backup out of RDS though, because it is a managed service. But it depends on the engine. We'd have to look at that. Yes?
Link server, does the SQL Server engine support link servers? Or does it support it across the different databases?
Do you know what version of SQL Server Link Server requires? Does it require like enterprise or some? Do you know?
I don't.
Okay. I don't have an answer to that. I can tell you that SQL Server, do you have an answer?
Yeah,
Oh,
it's not supported. Link servers are not supported
Okay.
at all in SQL Server for RDS.
okay. And it probably has to do with the fact that there's some configuration that we can't give you access to from the host operating system perspective. Okay. Yes, sir.
You mentioned the failover times and then the replication schemes and all that. Do commits assure replication to the other copies?
Let me see, make sure I understand the question correctly. If a failover happens, we will apply all of the logs up from the checkpoint forward in order to get the standby caught up. Is that what you're referring to?
Are the logs out of are the logs on the other replicas though? Like, in other words, if a client has a committed transaction and the commit was local, is the data physically stored, or is it at least transmitted across to the other replica or region or whatnot?
Transmitted, I believe, yes. And I don't want to give you the wrong answer. I wouldn't mind taking your information just to dive deeper and get you the exact right answer on how. That's a little more granular than I have a full knowledge on, but I can take your information or give you my card afterwards, and we can sort into it. I get time for 2 more, maybe.
Any plans to offer support for Oracle Spatial?
No idea on that. Once again, it's probably something the service teams are maybe looking at, and those are really driven by customer feedback. So if you're a customer now, please file a support case around that and the use case, because they want to be able to see that and know what people are looking for from that. Okay.
Scott,
Yeah.
you talked about scaling up compute capacity on demand. Is it possible to scale up storage capacity at the same time?
So you could, the same APIs. So if you determine that, okay, let's say I provision 2 terabytes and I need 4 now, you could actually use the monitoring metrics that tell you where your storage is and call APIs to add more storage to your database engine. The way it actually takes a while, it'll do it automatically, but it takes a while to actually provision all of the new storage on the database engine. We actually have public docs that talk about it and do that, but you could do that through APIs and through monitoring and even through that Lambda stuff as well. Yep. And that'll be the final question right there.
All right. I know SQL Server has some restrictions in RDS for some of the features that aren't supported. Do you know if the migration services allow synchronizing data from SQL RDS out to another database like SQL and EC2?
So I know that the database migration service I talked about at the end definitely can. It can take any 2 sources and replicate them. You can even replicate off of RDS and back into your own on-premise data center if you so choose.
Okay.
Yep.
Thanks.
Cool. Thanks, everybody.